Today we're going to be talking about expressions and formulas. And the first lesson, this is about order of operations. So you want to remember our 4 steps for orders of operations. Evaluate expressions inside grouping symbols. So things like parentheses, things like square roots, absolute value signs. Evaluate inside there first. A lot of you guys are used to thinking about that as P. And then any powers, many of you are thinking exponents. Then we go through and we multiply or divide from left to right. You can do those all at one time. And then add and subtract, which I formed PEMDAS, which you guys are used to. Something that I remember when I was a student is this was an acronym for please excuse my dear Aunt Sally. So that would tell me what order I'm going to be doing my order of operations in. Our first example, we're going to be evaluating the expression. I give us A, we have B, and we have C. So we're going to substitute in. So we have 6A. A is a value of 2/3 minus C, which is a -2. That's all over C squared, which was -2, minus A, which was 2/3, times by B, which was 9. So we go through and we simplify. 6 times 2/3. Remember, that's like saying 6 over 1. The 6 and the 3 can cancel to become a 2, so I have a 4 minus a negative plus 2 on top. -2 squared is 4. 3. The 3 and the 9 cancel to be 3. So I have 4 minus 6. So I have 6 over a -2, which is going to simplify to be -3. Today we're going to be talking about properties of real numbers. So real numbers are first what we're going to be talking about for about half the year. We're going to get into imaginary numbers later on in the year, but everything we're going to be talking about for right now is real numbers. And then a subset of the real numbers can be split into one of 2 major groups. Rationals, which has the abbreviation of Q, or irrationals. So here we have our Venn diagram of all of our real numbers. And notice how we're divided between irrational numbers and rational numbers. Rational numbers are anything that I can write as a fraction. Irrational are things like that we can't write as a fraction. For example, one we're most familiar with is pi. Or non-perfect square roots. They have the square root of 3 written there, or the square root of 2, and so on. Then a subset of irrationals are integers, and their abbreviation is Z. And integers are basically positive and negative whole numbers. So you could think about it like that. Whole numbers are just the positive version of integers. Integers are positive and negative whole numbers. But notice what they have here. The square root of 36, well, that simplifies to be 6. So if you can simplify that radical, that's going to fall into a different subgroup. And then we have natural numbers. So our natural numbers, another thing you can think about those is counting numbers. And think about when you first started counting, you didn't count with 0. You first started counting 1, 2, 3, and so on. So your counting numbers start at 1 and go on forever. So whole numbers include 0. So the only number that is a whole number that's not a natural number is 0. And then we move into positive and negative whole numbers. So natural numbers, smallest group. The only number that's a whole number that's not a natural number is 0. Now, integers here, this is positive and negative whole numbers. So it incorporates all of our whole numbers, but then the negative version of all those. And then rational numbers are all of our fractions. Okay, name the sets of numbers to which root 6 belongs. Well, root 6, we can't simplify it. And for right now, everything we have right now is a real number. So it's going to be part of our real number subset. Since root 6 can't be simplified, that's an irrational number. It's a number I can't write as a fraction. Now, if a number is irrational, it can't be any of these subsets of rational numbers, which are integers, whole numbers, and natural numbers. Our second question, name the sets of numbers to which 5 belongs. Well, it's a real number. I can write 5 as a fraction, so therefore it's a rational number. It's an integer. It is also a whole number and one of our natural numbers. So it's all 5 of them. But notice how it's not rational and irrational. It can only be one of the two. Now, negative 2/3. That's a real number. Negative 2/3 is a fraction, so that's a rational number. An integer is a whole number, a non-fraction, so it's not an integer. And whole numbers and natural numbers are subsets of integers. Or it has to be, if it's an integer, it's also a whole number or natural number. So for 1C, it's just real numbers and rationals. Some important properties that I want you guys to remember. Commutative property, under addition or multiplication, commutative is when they switch places, under either the addition sign or multiplication sign. The associative property, you associate different numbers under parentheses from one side of the equal sign to the other, and you see that on both of those. The identity, basically what can you add or multiply to get it back to its original. So under addition, I add 0 to get back to A. Under multiplication, we multiply by 1 to get back to our original number. Inverse. Inverse and identity kind of play into each other because inverse, what number undoes that to get me back to 0? Well, I add the negative version of the number. But for multiplication, it's what number do I multiply by? So it's the reciprocal to get me back to the number of 1. Closure is basically what happens when you have two numbers, you add them together, you get a number that is also back in that subset of being a real number. I wouldn't worry too much about closure. And then the distributive property, well, that's key. A number gets distributed to everything inside the parentheses. Okay, name the property that's illustrated. So you have to see, okay, what happens from one side to the other side? Well, what changed? You added the negative and the positive of the same number to get you 0. When you do that, that's our inverse property. For B, what changed? The 2 changed from being in the front to being in the back. It changed the location, so that's the commutative property. Three, got distributed inside. Our distributive property. And then for D, the grouping symbols changed. Here I was grouping together A and B. Now I'm grouping together B and C. That's going to be our associative property. Simplify now. So now we're going to be using our distributive property. Distribute the 3 to everything inside the parentheses. Distribute the negative 2 to everything inside the parentheses. Negative times a negative is a positive 18. So I have 2x minus 3. Now the next one, distribute the 2/5 to the 3a. Nothing cancels, so we have 6/5 a nothing cancels, so we have 18/5 b. Now distributing the negative 3/4. Negative 3/4, the 4 and the 2 can cancel, so I have a negative 3/2 b. Now what canceled for the first term isn't going to cancel for the second one, so I like to erase it so I don't make a mistake. I know I have a negative times a negative, so I'm going to have a positive. 4 and 8 cancel to be a 6a. Now combining like terms. I need to get a common denominator. The common denominator is going to be over 5. So I have 6/5 a plus 30 over 5a. I multiplied this 6a times 5 over 5. Now common denominator between those two terms is going to be 10. So I'm going to multiply 18 over 5 times 2. I'm going to multiply the 3/2 by 5 over 5. Then it's just a matter of simplifying. We have 36 over 5a plus a 21 over 10b. And it's okay to leave it like that.
Here are your lesson questions for this lesson. Please make sure these 3 questions are submitted with the Google form on time.